Hi, I'm Kent Lennartsson. I'm Research Manager at Kvaser. In the previous part, we could see why we need CAN to get a good real-time performance. In this part, we will show why CAN-FD makes it possible to increase the performance in your CAN system. To do that, we will use some animations. CAN is designed in such a way that no bits is corrupting during a collision. By prioritization, it is possible to have 100% busload without any delays caused by collision. With CAN-FD, it is possible to increase the bitrate from 1 up to 10 megabits per second, still without any delays caused by collision. The good real-time performance in CAN doesn't come for free. In order to evaluate the CAN frame priority, every bit needs to cover all parts of your system. And the bit is spread by the speed of the light. And if you have a system with less than 40 meters, it is possible to use a bitrate up to 1 megabit per second. If the cable is longer, the bit needs more time to cover the system and you need to lower the bitrate to say 250 or 500 kilobits per second. CAN is very responsive when it comes to controlling a car or a machine, but doesn't perform that well for video signals or larger data files. However, with CAN-FD it's possible to keep this good real-time performance, still with a higher data throughput. Let us see how CAN-FD is implemented into the CAN frame. The first bit in the CAN frame is the starter frame. This is a single bit that synchronizes all units connected to the CAN bus and start the priority process. After this bit comes the priority section, where several units could be sending in parallel during the arbitration process. The CAN frame with the highest priority wins access to the bus line. The following part is the data part that will be sent by the single winner of the arbitration. And after this data section, there is an end of frame that synchronizes the units in preparation for the next CAN frame. This ensures that it's possible to start a new CAN frame without any delay in between. CAN's limited bitrate ensures that arbitration works successfully in the first part of the CAN frame. The data section after arbitration is sent by one single unit. And when there is just one sender, it is possible to increase the bitrate. This possibility available in CAN is utilized by the CAN-FD standard. The beginning and the end of the CAN frame will keep the arbitration CAN bitrate to secure the real-time performance. This is the main difference between CAN and CAN-FD. CAN-FD increased the bitrate by switching to a shorter bit time after the arbitration process and returns to arbitration bit times after the CRC delimiter. This CAN frame has one single byte of data. However, in CAN it is possible to have up to 8 bytes of data. When data bytes together with data length code and CRC bits, all framed in blue, are sent at a higher bitrate, will it reduce the CAN frame length in time. CAN limit the number of bytes in CAN frame to 8 bytes. In CAN-FD it is possible to have up to 64 bytes of data. By increasing the bitrate on such large frame, it is possible to reduce the frame length considerably. The combination of CAN prioritized access to the communication and higher bitrate in CAN-FD makes it possible to combine advanced real-time performance with high data throughput. Your system can be optimized by using CAN-FD technology in 2 different ways. Either CAN-FD makes CAN frame shorter in time to decrease the delay and increase real-time performance, or put more data bytes in the CAN frames to decrease the overhead. Of course, it is possible to combine those 2 features by putting more data in the CAN-FD frame and still make them shorter by increasing the bitrate. Welcome to CAN-FD. CAN-FD will bring you better real-time performance and higher data throughput in your existing CAN systems. With CAN-FD, you will get this higher performance with minor changes in your software, hardware, and the tools already in use today. Good luck with your CAN-FD project, and if you need more information, go to kvaser.com. Hope to see you back soon.